gentlemen.
Oh, hello, boss.
But
Yeah.
things are good. We start with the comment about the road application. Okay, so the application will be we would like to introduce the report region because the road application is not really show the good things to our customers. Okay, so hope you guys can learn about this road application. We start from basic, and that's what we start with this construction. So that later on you move to road application. Okay, so basically spend a lot of time to prepare the slide. Okay, hope you enjoy it. Okay, PD.
Thank you, thank you.
Hey, good afternoon. If you can see on the screen, the title of the WebEx session today is Basic Road Survey Theory and Instruction, like a road survey solution. This is our fourth WebEx session for this year, first Technical Support Asia, and this is the first of the 4 road WebEx sessions that we have prepared to hold in this year. Not necessarily continuous, but we have we divide it into 4 different sessions because road subject and application and software can be. It's easy for those who have done it or those who have some experience in it, but it can be quite a lot of things to learn or share for those who have not coming from the surveying background. So I will proceed with this. At any time, if you have anything, you can note it down first, and then we have a question session later. Okay, and after this WebEx session, I will share the materials with you all. There are some sample data and sample jobs that you can use to for your practice and exercise later. Okay, first of all, have you all seen this poster before? Anyway, this is a poster that actually you all can order with the article number there 762303. This in the future will be easy for you to use as demo tools.
Hey, hello, today your voice seems to have some noise. Some noise.
Okay, maybe because we have 2 mics here, 2 computers. Can you? Is it okay now? Better?
Yeah.
Is it better now?
Better now.
Okay, thank you. Okay, the objective of this WebEx session is meant to really share about not to teach about road constructions or road design theory, but more for sharing of knowledge about road construction, the stages involved, surveying work involved. The objective of this WebEx session is as introduction to road construction and road surveying. Okay, can I suggest that if we have no other things, can you all just mute your first until the questions and answers.
We have one GR10, but it's not because the GR10 we have inside, it is coming, you know, it was coming from Spain. No, the 2 GR10s we had before.
Okay. Second objective to introduce to lighter road survey tools and solutions and enable the participants.
GR10, I'm quite sure we sold all of them. We still here.
to enable all of us to have a better understanding of stages involved in road construction and know what we have, the Leica products that we have available for many surveying tasks in road construction. These are the contents that we will cover this session. The basics of the road survey theories, stages involved in the road construction, the road design elements, and then the second part of it, introduction to the tools that we have, Leica tools that we have for us to input the designs, data or information into and transfer to the instruments, and then a little bit of showing or demo on the road 2D and 3D on FlexLine class. Okay. Introduction to roads. There are many types of roads. You can see there are simple roads like this that maybe just have two ways. This is also an expressway with quite straight line, but still you can see the curve, and then they are going downhill and uphill. So there are slopes and all that. So this is a simple road. And you may have roads that going through tunnels and also have head walls to construct and things like this. And you may have road like this with multi-layers of slip roads and intersections. Okay, components of road structures. Further, to carry on, to construct a road like this, if going through hills and some ground area, the ground may not be flat. We may have to cut through hills. We may have to backfill to the slope, and allowing the drain to flow through, we may have to build culverts. And of course, we have to lay the road material to build the carriageway of the roads. So there may be subgrade and base layer, and then the finishing road layers. These are the typical components of a road structure. You will have the carriageway, which consists of a few layers of materials, different materials, from the subgrade to base, coarse, gravel, and then binder, and then asphalt materials on top for smooth running of the vehicles. And on the road, you have carriageway, you have the shoulder, and then there's slope, the verge and the slope, and also you have drain. Drain also have different type of drain. Some is covered, some is open drain. The next stage of content is the stages of road construction. So these are the stages of road project. Before I go into it, you can see that many are highlighted in green. Okay, first we start with feasibility studies. Normally the authority will come up with a feasibility study to know where they want to build the road, from which point to which point, or from which town to which town. And then they will decide which is the shortest and the most economical path. And after that, there will be a process of right of way acquiring of land, meaning that they will acquire lands. If there are any private lands on this path, they will have to acquire the path, so it takes quite some time. And further to that, after the decision been made, they will carry out geotechnical data collection, and then existing ground survey, and after that, design the road according to the data collected. And further to that will be the construction stage, where the surveyor will come in and do the stakeout, and the contractor will come in and do the construction. After that will be the as-built of survey of the road. Okay, I'll go through some stages that a bit more details, but for introductions only. Okay, geotechnical data collection. There will be geotechnical instruments that deploy, but before they can deploy the instrumentation to collect the geotechnical data, they will have to survey the locations, like borehole locations and all that. And this give us opportunities to sell our instruments or our product for collections of this setting up of this position. Okay, so it will be something like this: a path that proposed, and then you can sell your either GNSS or total station to set up the locations for them to do the boring or boreholes and collect geotechnical data. Okay, so the geotechnical data will be collected along the path of the proposed road, and then the borehole, the geotechnical team will come in and do the drilling and collect data, sample of the ground texture. And after the geotechnical data collected, they will produce geotechnical data drawing and know what is underneath the surface of the ground, to know how deep they would have to excavate, or how much soil they have to remove, or whether they need piling or what kind of material to use. And the next stage of it is the pre-construction survey. Before that, the next stage actually is the design of the road. It's pre-construction survey. So they have to set up the center line of the road. Before they can set up, they will have to do a precise control survey. Okay, so before the construction, they will do the control survey properly along the center line of the road proposed. This requirement is quite rigid, that they must have a precise survey carried out, and ever setting up the survey for the road construction, and take care of the coordinate system if they are crossing border, either from country to country or state to state or region to region. Depends on the coordinate system that they use. And then we, like our solution, we have some good applications that we can sell now for this job, like sets of angles, traverse, or smart station. And now we even have the if the road going through some very deep jungles and all that have no wide RTK information data available, we can also sell our smart link or smart field data service. And then after the survey, if especially using our Leica instruments, we can sell them the infinities adjustment modules for importing all this data either from TPS or GNSS or level. Remember that we also have to do precise level so that the cutting of the can be done accurately. And all this data can be transferred to Leica Infinity without any problem. You can and adjust with this square adjustment and come up with a very comprehensive and detailed report. So if you are using other adjustment software or other computation software, you may have to do the conversions of data, which may take a bit of effort. With Leica Infinity adjustment, it will be very easy. Okay, before the survey is done, it's like a blank sheet of paper that you don't know where is the road going to be built. So with our survey instrument and road application, we can then set up the center line and the right of way, which will cover the area where the road is going to build, the path where the road is going to be built. And then we also need to survey the existing ground, collect all the information, either building or trees or whatever features that we have along the path of the road. And later we import this data into a software that will be with our Leica Infinity. You have seen it during our Bandung training that we can import any proposed survey data very easily into the Leica Infinity and plot it out, and we can then generate contours and DTM. DTM is digital terrain model, which we can use for our volume calculations and creating surface. Okay, the next stage of the road construction project will be road designing. To design alignment and the profile, vertical profile of the road, we will have to base on the existing ground level and also the geotechnical data collected. And the engineers will work out what kind of curve to use and how much gradient to apply to the vertical profile and all that. So with the design information provided, the contractor would then need to do the taking out of for various stages of the road construction. Excuse me, can everyone please mute your mic first? Thank you. Okay, so first we will need to do excavation or filling up of a certain area of the road path, and then lay each layer of the road for construction. Okay, during the construction stages, there are still a lot of progressive survey to be carried out. For claim purpose and also for monitoring of the construction progress. So all this will need survey work to be carried out properly. Okay, this following will be some pictures of various stages of constructions of the road and related to surveying. So this you can see we have a Leica instrument set up there. To set up packs, if you can see on the screen, there are packs for marking of how much, where is the location of the road and how much, what is the level to cut to and so on. So these are the survey packs that you have to pack on along the road. The road can be a simple road like in open area. It can also be something in the middle of town and for either diversion or expanding of new roads, expansion of new roads. It can be columns, it can be intersections and all that. So the first stage of the work will be, after the setting out, will be earthwork. It will involve cutting or grading or filling up of along the road alignment that we the surveyor has set up. There will be some more difficult surveying tasks, like for the slope cutting, and this we also have the applications on Captivate. If you next time when going to captivate the road, we will show you these functions and all that. For now, just show you the pictures. So this is a slope tag in the, you can see, and that's how it looks like. And then there will be cutting or drain, can be open cut or putting in the culverts. It can be also tunneling if you are going through mountains. Then they may have to build a tunnel through the mountains or build bridge to connect from through the valleys or rivers. And if it's a large-scale road construction project, you may want to think about machine control. I know this may be, if to some of you may be a bit, maybe thinking that it's difficult to sell this, but you can contact us and then get Owen to introduce to you what system to supply. Because with machine automation or machine control, it can really improve the productivity and efficiencies. In our Singapore here, there's a project in Changi Airport, which there was a contractor who were behind schedule during their constructions of the runways and taxiway in Changi Airport. After they purchased 4 systems of graders for machine control and rented another 4, they managed to catch up with the schedule and overtook even the better performing contractors, and they are very happy with that. Okay, so after the excavation of filling of the subgrade, they will have to lay various material layers. It can be gravel, it can be sand, and then finally will be the coarse material of the fine materials for the road surface. So next will be the as-built survey. So that will be last stage, that we are to collect information of the as-built of the road, and then we can use again we can use Infinity to import into the Infinity, and then we can produce the now Infinity with the new version. We have cut and fill reports, which can also produce calculations of volumes for their reports. Okay, the next items on our agenda today will be road design elements. Okay, for road design, first the road design will have to take into considerations of available and existing land. So we can't simply design according to whatever they like, but they have to see what are the available land and how is the existing conditions like, and then expect what is the expected volumes of traffic, the weight, the dimensions of the road that they want to build, the speed of the vehicle that's going to travel along, and then the drainage systems that they're going to use or construct, and all this will affect the safety of the vehicle traveling on it. Okay, give me a minute. Okay, excuse me, I'm just recovered from flu. Okay, the next slide. This is introduction. So for road design, there will be horizontal alignment, which was depend on the road, the ground condition, how much curve or straight line which are the straight and which are the curve to design to be considered in the design process, and then see whether they are hilly area. Then they will have to consider what gradient to put into the design to save cost of cutting and filling. So all this the engineer will have to take into consideration. Of course, they will want to minimize the cutting and filling, and also build the road as straight as possible. And when we talk about curve of the road, there are many types of curves. There are simple curves like this. There are also reverse curves that you go from clockwise and then to anti-clockwise. There are also compound curves that have two curves of different radius, and of course there are spiral curve in and spiral curve out. What you see now on the diagram is a typical horizontal alignment diagram. I just want to introduce some terms that you will some terms that you will be probably come in touch with, some terminologies. Okay, you can see here I have straight lines, and of course you see the changes, and then when you want to turn, you will have to have a curve, and then before you go into the other elements of the road. So as when you come into curve, normally you will need a smoothing of the curve, that you cannot simply apply a curve that is too great, that will cause danger to the vehicle using the road, because it may skid. So you need a spiral curve, like slowly changes from a straight line into the radius curve that you will apply. So that will call the spiral in. And after the simple circular curve connecting from spiral in, you will be spiral out. So that will be another spiral curve from curve, connecting from curve to into another section of the road. Can be straight or can be another curve. And you can see that these are some terms that the contractors or surveyors, or the surveyors on site may be asking you or talking to you. So TS is the tangent to spiral, ST is spiral to curve, CS is curve to spiral, and ST is spiral to tangent.
นี่ไงต้องมีคำว่า disconnect กับ switch audio อะไรเนี่ย audio connection แล้วก็ call
Hello gentlemen, and ladies, if any, sorry,
audio
because whatever you all speak, it can be heard by everybody, so it's kind of disturbing. Can we lower down your volume when you want to talk, so that not disturbing others? Thank you very much. Okay, so in some applications of any software, surveying software, you may need to input. For our Leica modern software now, we just need to input for spiral curve, the radius and the length. But in some old application, you may need to input the parameters which you can calculate using certain formulas. This one will come to it in future, but I have it in the PowerPoint and I will share for you all. Okay, for the vertical curve, so there will be either parabolic curve, which is defined by the gradient coming into the curve and going out from the curve. Sometimes they call it gradient in and gradient out. Sometimes they call it gradient 1 and gradient 2. And then for straight line definition is quite easy. It's just straight, and then what is the starting chainage and the end chainage of it to define how long it is, and what is the gradient. The gradient normally is given in percentage. This is a typical cross sections of a road drawing. So normally you can see that definitely every road should have the center line, and then there will be a fall for the water to fall out of the road, and normally this is given in a percentage, either 2% or 3% or whatever, and then you will have a slope beside it for the shoulder or a longer slope. This will normally be given in ratio of horizontal, vertical versus horizontal, or horizontal versus vertical. Depends on region. Okay, then there will be drain and offset. Okay, so you have center line, and then you have offset. How much offset to apply, and then what's the width of the shoulder you want to have, and so on. Okay, now we come to the next stage of our session. Design data input tools. These design data input tools are all, it's the Leica's tools that we have. Is alignment. So we have for Viva or Captivate, we have alignment editor, and then if those are very familiar with LGO, we have design to fill, which until now we are still using the design to fill for preparation of the design input to the instrument. But with Leica Infinity infrastructures module, we can also now prepare the design input using Leica Infinity's infrastructure. This is a more modern software. So this is the next slide. Okay, road survey solutions, onboard application. For FlexLines products, FlexLine Plus, we have Road 2D. For TS06, we have, this is optional. The Road 3D is optional. And then later I will cover a little bit as introduction to Road 2D and 3D. And then for Viva and Captivate instruments, we have alignment editor, which we can input the alignment design data directly into the instrument for roads and rail. And then now we are talking about road, so just road, we can actually input the alignment or the vertical profile or the cross section using the alignment editor, element by element. And then of course we have stake road. Stake road is to set up the road for construction, or for either for cutting or for laying. And then for check road is for the as-built. So the as-built is not just on the final layer, but it also applies when we build at each layer because of volume calculations of material use. So for Viva, we also have the same thing: alignment editor, road stake, and road check. So for input on the desktop, I say we can use Leica Infinity infrastructures module to create alignment and vertical profile, and then we can use design to fill. Sorry, wrong spelling. Miss a D. And then we can also import DXF file or LangXML or other format from third-party software into Leica Infinity, and then convert into format that our instrument can take or can use. So next, for onboard alignment input, this is how it looks like. If you go into alignment editor of Captivate, you can edit the horizontal alignment, you can edit the vertical alignment, you can edit cross sections, and assign cross section to different changes. In our next session, we will show this. For now, maybe to some of you, you already understand, because at different changes of the road, you may have different cross section, which you may need interpolations. And then also we can edit the chainage equations. This is for different length of roads, like for example 2 bounds, different length and so on. And we have to convert to jog so that we can use in different measurement, daily measurement. And for road 2D, we can input the alignments element by element. So Leica Infinity Infrastructures, the features that we have in Leica Infinity Infrastructures. This is a very modern software, so a lot of things can be visualized from the screen. So can import various data formats, design elements, XML or string lines, and then can handle multiple alignments. We can input if we have different alignments, many line of roads or sections of road with different alignment name. We can input it in different it can handle many alignments at the same time. We can assign the cross-section changes and create road objects. Because the road consists of different layers, so you can actually create different layers using the create road objects tools in Leica Infinity. Maybe I just show you very briefly. Okay, I just show you what is available on the infrastructures menu. You can see that you can actually create alignment and you can create roads. So when you created them, there will be objects in the library that as what you have created or defined. So all this we will learn in the future sessions of WebEx. So this now is just for introduction. So in this you can see that there is creating cross sections, material layers, and so on. Okay, for design to fill. For time being, the Leica Infinity infrastructure is still not ready for preparations of tunnels and real alignment. So we may still need a design to fill if we are dealing with tunnel projects. So if other than that, we can just use the Leica Infinity to prepare. So design to fill can help us. It's an older software. It handles GSI format and or it take in XML format and export XML format. Also can export to the SmartWorks Viva format. And like I say, you can prepare road, rail, or tunnel data and create cross section and assign cross section changes. And when you have to use a design to fill, you may have to install the design to fill importer so that you can take in more imports options, different type of data file, and export DBX or save into XML format and use it on board the instruments. Okay, this Leica Viva or Captivate's alignment editor, as I have mentioned earlier, for input of element by element. Okay, the next part will be a brief introduction to our Road 2D and Road 3D on FlexLine Plus. Okay, Road 2D and Road 3D on FlexLine Plus. I have actually prepared the slide and included in this material here, or the PowerPoint here, so you can use them. I will share it later. So for Road 2D, that means there will be no height involved. It's two-dimensional, so you can input the horizontal alignment, and it's one element at a time. That means you input from, just now I introduced to you all the typical elements of the road, like straight line, spiral curve, or a simple curve. All this you have to input one element at a time. And for Road 3D, it takes in GSI format. You will have to import it as, you have to name the file using road editor from the design to field, and then name it as with the format, the file convention start with ALN and then whatever name you want to give, and with extension GSI for horizontal alignment, and for vertical profile you have to name it PRF and continue with your file name and end with extension GSI, and then use the use the transfer this transfer tools to import it. You can import one file at a time, and then select the alignment file, and as you import into the FlexLine, our FlexLine is actually simple but quite intelligent, that you will straight away import into the database of FlexLine as the design of the road. And later I'll show you when you imported it, what you will see in road is something like this: horizontal alignment, what is the name of the alignment, and vertical alignment, what's the name of the profile. So once imported, it's in a .db format, in which you don't have to know about it, but that is how it is done. And in Road 3D, like FlexLine Plus, you can only keep one design at a time. So that is introduction, and I also include some design data for you all to play with if you have free time. When you, for those of you who have already have some ideas about road, you can start using the data to do some testing or practice. And FlexLine Plus Road 2D, I prepare all this. You can actually use the data that I going to share with you all to set up. And for this Road 2D, actually you can just input it directly. First you must have the start point, end point defined. So I name it the point of beginning or end of the straight line or whatever for straight line. And then after that you can put in the chainage and then do your setting from there. Remember that you must have your station, total station coordinate input near the line that you are going to set up, and then when you are measuring, it has to be in the section of elements that you are going to set up, else you can't see it on the screen here. So that's how it works. so you have to follow these rules. I also included the spiral curve setting, so you can also use this guide for spiral curve setting out. You have to input. You can select radius and length, like I said just now. So when you go into Road 2D, I show you on the simulator, you can select straight line, curve, or spiral. So for straight line, you just have to select the start point and end point, and then after that you will calculate the bearing, and then you just have to enter the changes that you want. You can also include a incremental value for how many meters interval that you want to set up. And then for spiral curve, again you need to put in the start point of the coordinate of the start point, and let me go to select tangent to spiral, for example. This is why I name it and I define the coordinates there. So I select that point. End point, again I can select from the list if I want to. Spiral to curve. You don't have to necessarily name the same. It's just that I want to, for my demo, I want to choose I have already defined the coordinates, so I want to make it easy. And then once defined, the method that you can choose is by this. You can just click, like I say, you can choose radius and length or radius and parameters. And the formula for the calculation of the parameters I have given you, but it's easier just put in the radius, for example 1000, and then the parameters. When you select radius and length, you don't have to enter the parameters, so you just have to enter the length of the spiral curve. Allow me to go back on that typical alignment, horizontal alignment diagram to show you what is the length of spiral means. Okay, the length of the spiral is the chainage, this chainage minus this chainage. That means from the spiral to curve minus tangent to spiral. These two chainage, when you take the deduction from it, you will get the length in between these 2 points. Okay, so after you enter the length of the curve, spiral curve, click OK. Then you have to define whether it's anti-clockwise or clockwise. Anti-clockwise means it turns against the clock and or following the clock. So, and it's spiral in or spiral out, you have to choose, and then you say OK, continue. Now you are ready to do the setting up. If you have you have to define the starting point chainage. Sorry, so you can be any chainage that following your drawing, and then you say stick or check. So you want to stick up or you want to check. Check means that you just measure any point, and then you tell you what is the offset and what is the chainage of that point. Stick means that you want to stick a particular chainage and particular offset. For example, chainage 110 and offset 2 meters or 3 meters. You can use the stack to do the stick up. Okay. So this for curve. For circular curve is a bit simpler. So again, you need to put in the radius of the curve and then tell it is anti-clockwise or clockwise, and then select select which result you want to use, because for the circular curve you may have two sides of the two centers, so you choose which one you want to use and put in the changes again, and after that, like I say, you must be within the elements. Then you can see, you can set this bull eyes on, and then you can see whether you are in the chainage and offset that you want or not. And this is for road 3D, a brief demo. Again, I'll just show you briefly. Okay, so road is in the program, and in this tab, road. First, like I say, you must first set up your station positions near the section that you are going to do the stick up or do the checking. After you do the station setup, you go to road, select road 3D, and then say continue, and select the alignment and the vertical profile that you want to use. You can view them if you want to, and check each of the elements that you have entered, and then say continue. You can also choose other profile, other alignment if you want to, and then say continue. So once you have selected them, you can enter the offset value if you want to offset them, and offset left, you can have different offsets on the left and on the right. For example, you want to have 8 meters on the right, 5 meters on the left, and then height difference. So for each layer of the road, there will be height differences, like I show you on the typical road component. You can see that there are different layers. They will be given a height difference, so you can offset it. Like for example, if the road vertical profile is given for the finish level, you can say that is minus 0.5 or whatever, and then define chainage that you want to set, for example 26760, and what increment you want to use, and do the stacking up. So once you are near to that, you will tell you how much you have to move to go to that point. So for example, if I set it near, then you will get, as you get nearer, you will beep. And so the setting up is quite easy to use. You just have to have some basic understanding. Okay, so I think that's about all for my demo. Now is time for question and answer. Okay.